Hello, I'm Junjian. Please allow me to introduce the work conducted by my colleagues and me, CamTroller, an auxiliary tool for controlling your avatar in PC games using natural motion mapping. Motion control is not something new. Actually, its history could be traced back to the 1980s. However, it was not widely distributed to the public until 2007. This year, Nintendo, the company famous for Super Mario, released Wii U and started the game revolution of motion control. A large number of consoles with the motion controller sprung up after the Wii U. Motion controllers are more intuitive and easier to use since they capture our body motion as input. We don't need to learn or memorize the mapping relationship between the keys and the avatar's motion. However, a great number of players still prefer gaming with keyboards, mice, and gamepads over motion controllers. Even with relatively major VR technology nowadays, they still prefer gaming on PCs and consoles. Why aren't these players embracing more immersive and intuitive gaming experiences? One important reason is that gaming entirely with motion control is exhausting. Physical fatigue can quickly tire players and limit play time. Moreover, it will damage the gaming experience. To solve this problem, Nintendo shifted the role of motion control from primary to auxiliary. Motion input is used for supplementary actions or as an alternative for buttons and joysticks. Sony and Microsoft also deploy similar strategies in their games. Regular gamepads are now commonly integrated with IMU for sensing motion so that motion control does not require a specific controller. Because of that, console players are more or less using motion control in games as auxiliary input, depending on their gaming habits.
Motion control has found its place, and now players can enjoy it without getting tired. Wait, how about the PC players? Do they get something new? Why does it seem that most of them still game only with mouse and keyboard? Well, they do have something new. Passive checkers like Check IR or active checkers like Check IMU are available for them. Motion checkers originally designed for consoles, such as Kinect, can also be used on PC. However, the game has to get native support for motion control, but most PC games do not have it, except for driving simulators. Besides, the actual cost of motion sensing devices decrease players' interest in trying motion control. Even though some researchers successfully achieved motion tracking using only competitive RGB cameras with the help of AI, their work was limited to specific self-developed games and not very useful for most players. How can players conduct motion control in commercial games? Tilted, created by Achille Zhang, is a good reference. It is similar to other active tracking devices and uses IMU to sense motions, but it emulates keystrokes and mouse movements based on motion data instead of sending them directly to the computer. This great idea enables motion control without the need for native support from the game. Tilted is small and can be easily mounted on the headphones without causing a noticeable load. Although it was relatively cheap, it sold poorly and quit the market soon. According to a complaint that we saw in the discussion forum about this product, one crucial reason is that mounting something on the head is still inconvenient. Also, the inherent chip problem of IMU and the need for frequent calibration is really annoying. What if we combine the solution of using AI for motion checking and the idea of emulating peripheral? Then we can create a low-cost and convenient approach to achieving motion control for a large amount of PC players. Before exploring technical algorithms, let's determine if motion control as an auxiliary tool is necessary for PC players. By gathering information on different discussion forums, we found three typical situations that need motion control. Games with complex avatar movements and items require players to memorize numerous keybites, leading to a memory burden for beginners. If motion control is incorporated as an additional input method, it significantly reduces the requirement for memorization. Also, in the one-to-one avatar mapping games, it is a common condition that several keys have to be pressed at the same time to conduct multiple actions simultaneously. But sometimes these keys are assigned to the same finger, causing a finger shortage problem. Pro players can borrow idle fingers for other keys as the actual finger, but this advanced operation is challenging for ordinary players. Enabling motion controls provides ordinary players with actual fingers and allows them to conduct pro operations. Another one is about the consumption of items in the game. The keys for items are usually far away from the WASD region, where players place their left hand. Pro players can conduct touch time, relying on their muscle memory, while ordinary players have to look down at the keyboard to find the key, making them lose the view. Game designer tried to alleviate this problem by adding backpack menu, but its UI blocks other contents in the game scene, also resulting in the loss of the view. Besides, finding the desired item crowded with plenty of others is time-consuming. To further understand and confirm these needs, players of PUBG, a representative battle royale game with complicated motions and items, were recruited for a user survey. We collected 122 validated responses in total, and the result indicates that players do face these problems and need motion control. For more details, please check our paper. Since the need is confirmed, let's continue. We also chose PUBG as the test platform. Picking, crouching, jumping, free-looking, and consuming different boost items were selected since problems we discussed in the previous part usually happen when these motions are conducted. By observing the participants imitating the avatar's motions, we determined detectable parameters for different motions. Head angles and positions are suitable for picking, crouching, jumping, and free-looking, while finger flexion angles and positions are suitable for the consumption motions of different boost items. We need to find suitable algorithms for head checking, body joint checking, and hand checking. Although there are a lot of available algorithms, MediaPipe is the only one that provides an integrated solution for holistic detection. Moreover, it provides estimated depth data for the face landmarks, which enables the calculation of head flexion, extension, and axial rotation. Also, it has promising performance on the CPU, which means no requirement for specific GPUs and tedious setting configurations, making our tool more accessible to a broader group of players. Therefore, MediaPipe was chosen for this project. Although MediaPipe is powerful, it does not provide native head orientation data. We developed a function for angle calculation and evaluated its accuracy with a Mook head model. The accuracy is satisfying for the application. There is nothing special about the position checking of the head as well as hand checking parts, so they will be skipped in this video. We would like to mention more about our improvement in the trigger criteria of the head motions. Previous methods usually set the threshold on positions and angles. When the threshold value is reached, the motion is considered to be performed, and the input signal is sent. It is simple to apply but has a significant disadvantage. When the game has a motion animation, stability conflicts with the lag. This picture shows this problem more clearly. When the threshold value is large, to avoid unwanted triggering because of the random sway, there is a large lag. The threshold to a small value to reduce the lag makes the system unstable. Finding a proper value is hard and costs a lot of time. We added the linear and angular velocities to the criteria. When the head moves or rotates at a velocity above the threshold value inside the velocity zone, the motion is also considered to be performed, just like reaching a specific place or angle. Also, learning from typical strategies applied on the joystick, we added the depth zone to avoid unwanted input signals triggered by the velocity because of the head sway. This method reduced the lag while maintaining the stability. Graphical illustration can be seen in these figures. Here's a demo video of using CamTroller, the motion control software we created. After the video, please allow me to hand over the presentation to Dr. Yuqian Wang for the following parts.
Okay, it's time for user study. To compare the performance of CamTroller and the original keyboard and mouse input, we conducted 2 parts on the boosting item consumption actions and the peaking. To estimate both objective performance and subjective evaluation of CamTroller, the user study compared the basic strategy most players used, the pro strategy which professional players adopted, and CamTroller. For taking the energy drink, the basic strategy blocks the whole window. The pro strategy also blocks part of the window. While the CamTroller does not block any area. For the peeking during the games, the avatar will need to peek out to shoot the enemy while standing behind a barrier. For basic strategy, people click 1 key at a time. For pro strategy, players are trained to click on both keys to perform peeking while moving to save time, which is hard to perform. For CamTroller, the head movement triggers peeking while fingers only need to control the basic moving. The objective performance of peeking turned out that CamTroller is comparable to the Pro operation. The Pro and the CamTroller are significantly faster than the basic operation. There is an example. The subjective intuitiveness estimation showed that the basic and pro are no difference, and the CamTroller achieved significantly higher scores than the basic and pro. Thank you.